Okay, part 4 of section 10.2 is where we're going to put in some quotients. And so your first one is the square root of 64 over 49. First thing you need to recognize is that you're going to split it up so that you do the square root of 64 and do the square root of 49. Now something that I've seen is that some of you don't know what are perfect squares, meaning that if I did the square root of this number, it'd end up being a nice whole number. So I listed them up through 12 up here. So 1 squared, 2 squared, 3 squared, 4 squared, 5, 6, 7, 8, 9, 10, 11, 12, so that if it matches one of those, this should be something you just plug in your calculator. So square root of 64 is just 8, square root of 49 is just 7, so that's how I know that ends up being 8 and 7. Now if you don't know that, you could still come over here and do your factor tree of 64, split it up as 8 and 8, and then do your pair, so there would be my pair right there. And I could do the same thing for 49. Split up 49, get 7 and 7, and 7 would be my pair. So you have either way. If you know it's a perfect square, just do the square root. Otherwise, you're going to keep breaking it up like we have before. So on the next one, I have 8x cubed over 50x, and I'm doing the square root of it. First thing I see is that I have x's on top and bottom, so I want to reduce this fraction. So when I divide 4 and 50 by 2, I get 4 over 25, and then when I'm dividing, I'm going to subtract those exponents. So that's how this becomes x squared on top. Now I can just do the square root of the top and the bottom. Remember, square root of top would be 4x squared, square root of the bottom would be 25. These are both perfect squares, so square root of 4 would just be 2. Then I would do square root of x squared and write it out as 2x's, so that makes a pair, so it also comes out. And square root of 25 is just 5. So some of these that you practice today shouldn't have any radicals in them because of the fact that they're nice perfect squares. So I want you to do A and B in the got it question. So in the got it question, we have square root of 144 over 9, so that should just give you 12 over 3, which will reduce to 4. So my answer should be 4 in the end. And then on the next one, you can reduce it first, so it would be 9 over a squared. Then you're going to do the square root of the top and the bottom. So square root of 9 would be 3. Square root of a squared would be a pair of a's, so it's going to both come out. So I would get 3 over a. Now I wanted to run through the last one together because it's a little tricky. It has the square root of 25y cubed over z squared. And in that, first thing is making sure that you still split up the top and bottom. Square root of 25 is a nice perfect square, so it'll come out as 5 as a whole. Square root of y cubed, remember we're going to write that out and get one pair. So one y comes out, but one y stays inside the radical. Then on the bottom I have square root of z squared, so 2z, so 1z is going to come out. So what ends up happening is on top I get 5 and this y, and then the square root of y still left over. And then on the bottom I had just a z that came outside of the radical, so it's just left by itself as well. So this one's tricky in terms of making sure that you split up the top and the bottom and do them separately, and then put them all back together, so finding those pieces.